Hello students, welcome to the Yupp Master. Today we are going to deal that the problems which are based on the derived quantities. Let's see that. Yeah, we would like to go for that derived quantities. All right. So the derived quantities are obtained from fundamental quantities. You have to get that. Quantities. Yes, these are obtained from fundamental quantities. All right, it's very clear. You can get this one. So we would like to have the related problems from these derived quantities. All right. Okay, let's go for that. Yeah, you have to get that. You can take that. Yeah, if you are going to get that, density is equal to mass by volume. All right. Now, if you are going to get that, convert that 1 kg per meter cube into CGS unit. Already we have discussed about that CGS and MKS system. It's very clear. So, if you are going to have the conversion, just you have to use this formula. All right. It's very clear. You have to use this formula. All right. Now, you have to get that. That is the answer. We can use this space. All right, it's okay. Just you have to get that 1 kg meter per meter cube. Okay, you can write down it as this is going to be written as meter cube. Very simple. So you have to convert into CGS. This is MKS system. All right, you have to write down there. Previously, we would like to get this one, that is 1 kg is equal to, that is equal to 1000 10 to the power of 3 grams. All right, 1 meter is equal to 10 to the power of 2 minus 2. Just let's see that. You have to get that 1 meter is equal to 100 centimeter, that is 10 power 2 centimeter. Just you have to write down. This is very clear. We would like to get this one. Therefore, 10 to the power of 3 grams by 10 to the power of 2 centimeter. It's very clear. So now you are going to get that. It's very clear. You can get that 10 to the power of 3 by 10 to the power of 6 centimeter cube. While you are going to have that density, that is in MKS to CGS system, you have to confirm. All right, you can get that value. It's very easy for you. Yeah, 10 to the power of 3 into 10 to the power of minus 6 grams centimeter inverse cube. That is, you will get that. That is 10 power minus 3 grams per centimeter cube. All right, you will get that. It's a very simple. Yeah, you have to get this one. All right, it's the answer. Okay, let's go for another one. This is the case. You would like to get that 001 gram centimeter inverse 3. Just you have to get this one. Very simple. This is the basic model question. You can get the answer. It's very clear. Now let's go for another one. Yeah, you have to get that. Yes, it's going to be multi-corrected answer. All right. So you would like to know about that Newton. Yeah, it's very clear. Newton is a derived unit in SI system. Just we have to get that. Newton, it's a derived unit to represent the force. All right, it's very clear. You can get this one. This is in SI. You have to get that. All right. Dyne is also, you will get that dyne is also derived unit to represent the force. Is a derived unit to represent the force. All right. Now it is very clear what they have given the answer. Just you have to see that 10 power 6 dynes and 10 power 5 and 1 Newton, 10 power 5 Newton. It's very clear you have to get that multi-corrected answer, okay, whether more than one answer is going to be correct. This is all about that representation of force in different units you have to get in dyne and Newton. All right. Now you have to take this one. Yes, you know, force. You have to get that mass into acceleration. It's very clear. You're all knowing about this. Yeah. Okay. 1 Newton is equal to, you will get that 1 Newton is equal to 1 kg meter per second square. Just we have to write down. It's very clear. All right. It's very clear. You would like to get that. Yeah, it represents 1 Newton. Okay. So this is very clear. You have to get this one. This is correct. Okay. Now you have to check it. Yeah. Conversion. Just we have to Newton to dyne. 1 Newton into 1 dyne. Let's see if you are going to take that. Right. So 1 Newton is equal to 1 kg meter per second square. That is equal to, you have to confirm. It's very clear. You would like to get this one. Dyne, it's going to be in CGS. So it's a, you have to convert, that is 10 power 3 grams and 10 to the power of 2 centimeter. You will take that second. Time is in second, it has been represented. It's very clear. 10 to the power of 5 grams centimeter second inverse. Just you have to erase some part. It's very clear. All right. Now if you are going to have the look into the matter, just you have to take that 10 to the power of 5 into grams centimeter per second square. Just you have to write down, that is 1 Newton. That is you can take that. Yeah, 1 kg meter second square is equal to. All right. So it is 1 Newton. All right. It should be equal to 10 to the power of 5. It is going to be written as dyne. All right. From this one, we will confirm. It's very clear. All right. You have to get that 10 to the power of 5 dynes. So this is also correct and this is also correct. This is a multi-corrected answer type questions. Just you have to see. This is very clear. We would like to get this one. All right. Force and its representation in SI system, and after 1971 they are going to have that common domain of that SI system. MKI system is going to be modified as the SI system after 1971 by adding some other physical quantities. Alright, now let us go for another one. Comprehensive type. These type of the questions are given in passage type. They are going to give in the form of passage. Just you have to read the passage and you can understood the central theme, the meaning, the total meaning of this passage within 3 or 2 lines you have to understood. That is very important. Okay, fundamental units are the units for measuring the fundamental quantities, and derived units are the units for measuring the derived quantities. Alright, it is very clear. Do you know derived units are basically derived from fundamental quantities. Alright. So, you need to get that base quantities are very useful to derive that derived quantities. Okay, if you want to express the derived quantity in derived units, like that you have taken the Newton, it is a derived unit, dyne, it is a derived unit, but all these are going to be having the base depending on the base quantities like mass and length and time and all these things you can take. So, they are going to give that question. So, which of the following is derived quantity? Let us see that. Okay, you have to get this one. Yeah, you can take that impulse. So, it is very clear. You have to discuss about that impulse. What is impulse? Yeah, it is going to be change of momentum. Right? Change of momentum. It is very clear. So, otherwise you will talk that impulse is going to be having that, it is one phenomenon, you have to understood that, yeah, a large amount of force acted on surface within short period of time. Alright, it is very clear. We have to know that what is impulse. In your daily life you have that hammering, that just we have to get the physical observation, hammering. To grip the nails, into the wood. Right, you are going to get that. If you have taken that, this is a case, you have to get this one. So, with the help of the hammer, just you are going to getting this one. Yeah, this is the area. Yeah, you have to get this one. So, within the, as compared to the magnitude of the force, the surface area of the nail, it's very small, just the magnitude of force is large. And in the explosion of a bomb, just you have to see that the fragments of the bomb which are going to move with high speed as compared to their size, their speed, the magnitude of their speed is going to be large. So, they are going to act upon a force which produces a severe damage. Alright, it is very clear, hammering. This is the case we have to discuss about that impulse. Alright. Okay, it is very clear. We are having that very good idea about that impulse. If you know that, just we have to take that change in momentum and all these things. Generally, we are going to represent impulse is equal to force into time. You have to represent, this is going to be I. Alright, you know very well about that. Yeah, you know, force is equal to rate of change of acceleration. Rate of change of, it's going to be having representation. Force is represented as that rate of change of velocity into time. It's okay. Just you have to write down. Yeah. Force is equal to mass into acceleration. All right. If you are going to get that, therefore, rate of change of velocity into mass. It's very clear. That is V minus, you have to write, yeah, you have to write down, that is, yeah, you have to write V minus U by T into M. It's very clear. So, this is about to know force, you have to get that. Yeah, this is the first one, this is the second one. From 1 and 2 you can write down. What you have to write? Just you have to take this one. Let's take that impulse is equal to, you have to write down impulse is equal to, that is V minus U by T into M into T. You are supposed to get the cancellation Tt, that is Mv minus Mu, that is change in momentum. All right, let's have a look. You are supposed to identify this one, this topic. It is very clear. So what we are going to discuss about that impulse, large amount of force acted on surface within short period of time. All right, it should be represented as a change of momentum. It's very clear. Impulse can be represented as that force into time. If you know that force is equal to mass into acceleration, acceleration is going to be having that rate of change of velocity. Just you have to take that. Now you will find out this expression 1 and 2 and you have to get the substitution, right. So finally impulse, that is going to be mv minus, just you have to write down here, you can take that, it's very clear, yes, it's very clear. So what can you say about that impulse? You are going to get that impulse, it depends on another quantities. All right, it's going to be depending on that force, it depending on that change in momentum. Yeah, if you are going to take that momentum, that's going to depend on that velocity, initial velocity and final. All these parameters are going to be taken. Temperature, it is not at all going to be dependent parameter. Force, already we have discussed about that force depend on mass and acceleration. So as per the given question, you have to confirm which of the following is derived quantity. That is very clear. So straight away you can confirm impulse and force. So both A and B are going to be derived quantities, no doubt at all. We have discussed about impulse and its significance. All right. Okay, let's have that another problem. Just you can take. Yeah, you are supposed to have that another problem. All right. Just you have to see the magnitude of it. Generally, if you are going to take that, the representation which has been taken by parameters. All right. In measurements, we are going to take that P is equal to Nu. Just you have to take that. In measurements, you can take that. It can be represented as P is equal to N into, you have to write down U. You have to take that. Okay, I have taken that. This is very clear. You can take that. All right. What's that P represent? Magnitude. N represents that numerical value. All right, it's very clear. N number, it represents the numerical value. Unit, it's a defined unit, a well defined unit, it's very clear. The relation can be expressed as N is directly proportional to 1 by V. Yeah, it varies inversely with the unit what we have chosen. All right. Okay, if you are going to take the quantity, all right, if you are going to take that quantity, it remains same, but its numerical value depend on the unit. All right, if you have taken that 1 kg sugar, if you have taken that 1000 grams sugar, either in terms of MKs, in terms of CGS, all right. So you got that 1 kg, you got that 1000 grams, but the magnitude is same. For any physical quantity, its magnitude is same. It's very clear, no doubt at all. But you have 1 and 1000. That numerical value, sometimes it is going to be 1, sometimes it is going to be 1000. How it is confirmed? Based on the units what you have chosen. In order to measure the physical quantity, you have been chosen that higher order. Just you have to take that. That is in terms of kg, in terms of grams. All right, it's very clear. That's what I am telling you. OP is going to be magnitude. It's going to be magnitude. All right, it's very clear. Now you are all going to have that magnitude. It is going to be constant. All right, it's equal to constant. Now what can you say about this N? Now it is very clear. N is directly proportional to 1 by U. You have to get that. How it was confirmed? That is N. Yeah, you have to take this one. All right, you have to get that. Yeah, Nu is equal to constant. All right, you can take that. N is equal to some constant by U. So you have to write down that proportionality. You can express in terms of U, N in terms of U. That implies N, yes, you have to write down, that's very clear. N is directly proportional to U, 1 by U, it's very clear. Okay, what you have been identified from this, it's very clear. It is all about that representation of the magnitude of a physical quantity. Just you have to represent one physical quantity. Its measurement can be represented by the equation P is equal to Nu. It's very clear. What we are going to get the question, right? You have to see that. The numerical value, it's very clear. We have to erase some part. All right. Okay. What we are having that equation, that is P is equal to Nu. All right, this is the question we are having. This is the expression. What about that given question? If the numerical value of a measurement is less, then unit. So numerical value is going to be less. That is in terms of 1 kg. What we have discussed about this one. 1 kg, it is going to be having. But the unit is going to be kg, that is in MKS system. Unit is going to be higher order unity. So kgs, you can take that MKS, just you have to remember. Then the unit is, yeah, maybe large, maybe small, maybe decrease, we can't say. All right. Straight away you can take that N is inversely proportional to U, then it's going to be as that is less, N decreases, U increases. Very clear, you have to get that. Okay, it's going to be large. The numerical value is less, then the unit, it is going to be lower. Just you have to take that. All right, it's very clear. We would like to have this one. That is in terms of system of units, you have to get that. That is MKS system, CGS system, FPS system, whatever. Generally, you have to get that. The number, the numerical value increases, then its a unit, it's going to be lower order. Numerical value decreases, it is in the higher order. Just you have to confirm. Very clear. Yes, you have to take that. Fundamental units or the units for measuring the fundamental quantities, and yeah, that is the concept what we are having. So, we are having that fundamental units for fundamental quantities. We are having that derived units for derived quantities. All right. Okay, let us see what they have given. Okay, it's very simple. They have given speed. All right. Speed is equal to distance by time. While you are talking about that, yeah, distance, and you have to take that distance. So, it's going to be taken you have to take that actual path. Distance is equal to actual path traveled by the actual path followed by the particle. You have to get that actual path followed, yes, by the, just you have to get that particle, actual path followed by the particle or object. It's very clear. So, you have to get that. This is the case we are going to get that. You have to get, this is A and B path. Actual path, does it represent the distance? Just you have to take that. So, that gives the distance. All right. Okay. You are going to get this one. All right, it's very clear. While you are going to take that displacement, it's a time to know about these quantities. So, displacement is the shortest path. So, in order to reach the B, in order to reach that destination B, you need to having the different paths. You have that n number of paths. Let's assume you will move in this way, you will move in this way, and all this. But the direct, just you have to see, it's very important. It's very clear. You are having that direct path. So, it represent distance. It represent displacement. Okay, we have taken that time. It's very clear. We have taken that time is a one quantity, that it is very clear. Okay, we would like to take that length, actual length, just you have to take length and time. Length and time, these are very important, you have to confirm. All right, it's very easy to represent. Okay. Now, we would like to get this one. Yeah, we are going to take that, whether it's going to be represented with the fundamental quantity, that is length and time. All right. Okay, just you have to take that. Speed, distance covered, displacement, just you have to take that. Very clear? You would like to differentiate both the cases. Let's go for another one. It's very clear. We would like to get this one. So, the radius of the sphere is going to be doubled. What about its density? You know, density is equal to m by v, that is mass by volume. What happened if you are going to get this one? If you are going to get this one, yeah, we have to take that R changes, volume is equal to R changes, then volume changes. So that what they are going to discuss, yeah, if the radius of the sphere is doubled, R is going to become as 2R. So it's going to be taken 4 by 3 pi R cube. So you have to get that 2R cube. It's going to be 8R cube. Now it will goes for 1 by 8th of the original if you are going to increase the R value, double the R value. In this way we can solve the problem. It's not a big task for you. Okay students, have a nice day. Let us meet in the another class. Thank you.